All right, guys, who's out there who needs math help? Oh, anybody out there? Do 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 do. Wow, I went from 2 to 0. As soon as I get on, everybody gets off. They're like, "Whoa, no!" What's up, Coda? You know it's time to stream, huh? Come here. Come on. Oh. What? What? You good? Anybody out there? One person on Coda. One person. Nobody needs help with math. That's so depressing. He literally walked up to me, and then he's like looking at me like, "Hello." Ugh. What's up? Nobody cares. You get up. Hey, so I responded to your comment that n squared is actually supposed to be x squared, and it does factor. You get all your work done. Who cares? Or nobody cares? Look, Coda. Look this way. Look that way. Camera's right there.
Go to baby. Go to bear.
And we're standing behind a plane of glass. We're sitting behind a plane of glass. He's happy. I can do math with him in my lap. Ain't no big deal. I am wearing a red shirt. Not yet, huh? Should be getting done. You've been working on it for a little while. Should be getting done pretty soon. You have questions for me, or you just hear and work through it, and then if you have a question, you just ask? You looking for problems for me to do? I think it might just be me and nobody cares. There's 2 people on there, you and nobody cares. Oh, there's another person. Now we're up to 3. Odo, you got 3 people watching you. You feel the pressure? You feel the pressure, buddy? Feel the pressure? Do. Come on, went off. Oh wait, week 2, day 2, factoring the difference of squares, number 4 and 5. Okay. Week 2, day 2, 4 and 5. So they're similar. There's a trick to these ones. He wants down. Let me get him down. There's a trick to these ones. So they're really the same. So I want to work just one of them and let you work the other one. Let me grab a marker. So I'm going to do number 4. So I have 18x squared minus 50. And it tells me to do the difference of two squares on this. Well, there's a trick. I can actually introduce a square root into this and make an a, because like we talked about yesterday when we're doing difference of two squares, we have to know a squared minus b squared, and of course then that's going to equal a minus b and a plus b. All right, but in this case, we don't have a perfect square for 18, so I want to make a perfect square. Conveniently, if I took the square root of 18 and I squared it, that equals 18. So I'm just going to take the square root and square it at the same time. So I'm going to do the square root of 18 squared x squared minus, well, I'm going to do the same trick here, the square root of 50 squared. Now I can rewrite this as the square root of 18x minus the square root of 50 squared. And here is now my a, and here is my b. So this factors to the square root of 18. I'll put my x in front, plus the square root of 50, and then x, the square root of 18 minus the square root of 50. So that you have to know that trick to take the square root and the square to solve those two. It doesn't show one in the example. This is a common trick that we use to be able to use the difference of squares. It's just a trick. You can do the square root and square it of any number and just get that same number back. So then number 5 is exactly the same way. I'll let you do that. And I don't know if your teacher would want you to break the square root down, so I'm going to show you how to break them down. So the 18, we're going to do a prime factor tree. So 18, 2 goes into 18 9 times. 2 doesn't go into 9, but 3 does 3 times. I'm going to look for a pair, so I can rewrite the square root of 18 as 3 root 2, because whatever's left stays underneath the square root is the square root of 18. So I can actually rewrite this as 3x, the square root of 2. Now let's do 50. 2 goes into it 25 times, and then that's going to be 5 and 5. Here's my pair, so I can rewrite this as 5 square root 2. So this becomes plus 5 square root 2, and then 3x square root 2 plus 5 square root 2. And I can do some other things to it. Oh, minus. And I can do some other things to it because both these have a GCF, a square root of 2, and go from there. But if it's just a difference of squares, I'd have my students stop right here because this shows me you understand what's going on. This is just playing around and having fun with numbers. So I'll let you do number 5. Good question, though. You want me to go get you Carl's Ice? You'll need a couple of them. Alright, what else? I ripped all my erasers, so I got a whole stack of ripped erasers over here. Oh, were you? Probably is. Oh, is it? Yeah. Yeah. Well, I only have 2 people on here. Nobody cares to ask one question. She's probably going to work the other problem real quick and then look and see what other questions she has. So give me a problem. Okay, just give it to me. Just read it to me. Did you hear a house blew up in Cove today?
What all that noise?
Yeah, a house blew up in Cove today.
Okay. parenthesis 2.
Huh?
2 close parenthesis. Parenthesis.
Is it how much more? Oh, I need to.
Thank you. Thank you. Shit, no.
Yeah, no, it was on chat. All right. So it's open parenthesis x squared plus 1 squared minus 2x minus open parenthesis 1 minus x squared. Open parenthesis 2. Okay. Again?
Yeah. Plus 1. Close parenthesis.
Just that?
Yeah.
Is
It's
it
not long. It's in the middle.
okay?
Squared plus.
Okay. So to simplify this,
Yeah.
not really bad.
Yeah, I know it's not bad, but it's kind of what they're doing.
So to simplify this, this is actually algebra 2. I mean, technically it's not algebra 2. It is, but it isn't algebra 2. I want to factor a GCF. I'm looking at my first term here. You have to think of this as a term and this whole thing as a term. And I say I have an x squared plus 1 squared and an x squared plus 1. So I want to factor that out. And I want to have a x squared plus 1. And then I have a 2x and I have a 2x. So that's going to, I want to factor that out. I'm just going to put it out here. And in this first term, that's going to leave me with x squared plus 1 times a negative 1 minus, well, I still have my 1 minus x squared times my 2 times 2x. Oh yeah, you're right. Wasn't paying attention. Yeah, I factored this whole part out. So close parenthesis, all over x squared plus 1 to the 4th. Now we can simplify. There's one of these and one of these. That makes that a 3. Let's clean up the inside. So I have 2x. It's going to give me negative. This is actually a cool problem. This actually ends up becoming... you ready for this? 1 minus x squared, because I changed the signs and changed the rotation of it, minus yeah. No, I'll get rid of these parentheses. I don't need them. Because I was thinking this is going to be the same. So then from here, I'm going to have minus a negative, do right distribution, left distribution, so I get negative 2 plus 2x squared all over my x squared plus 1 now to the 3rd because I reduced it. Combine like terms, 2x, this gives me x squared minus 1. Yeah, x squared minus 1. That would have been cooler if this was this, because then I would have gotten x squared plus 1. I would have been able to cancel another one. All over x squared plus 1 cubed. Then you can distribute this last thing and have 2x cubed minus 2x over x squared plus 1 cubed. Pretty easy. I have square roots. I don't even need square roots.
I don't know.
I don't need square roots.
But all of us have for the square root times. But it's just.
Oh yeah, it should be minus 3. I dropped the sign. This should be minus 3.
Yeah.
So this would be 6. Do they
so they have that, right? Go further.
Why?
Their solution, I don't know. Their solution 2x times all over.
There's no need for that.
I don't know why they did.
Honestly, you can stop right here.
That's what I'm saying. Have that, but then they went further.
I wonder if they asked for something specific.
You know, it just says
adding a square root into a what would be a rational function isn't simplifying. It's making it more confusing. I'd have to look at that whole lesson because maybe they're doing something to build them up to something else.
No, it just says in the following examples and problems, the term simplify indicates to eliminate compound fractions, factor as much as possible, over denominators when feasible, and avoid negative exponents.
Which I didn't have any of that.
Right, so that's why I'm like, why?
They introduced a fractional exponent. Any questions? Any questions? Any questions? There's 3 of us in here now. Why don't you look up, oh, you know what I can do? I know what I can do. I had a math question emailed to me. It was a physics question.
Some of these word problems.
Oh yeah, that's why I make sure I pick word problems that are coherent.
John Steinbeck, all of which he grapes and
Huh. Wow, that's a healthy diet.
Right, that's what I'm saying. The price of grapes is $2 per pound, $4 per box. 5G. Steinbeck is a maximizer.
So you just maximize the function.
But why?
Wouldn't it make more sense?
He put the grapes in the tortillas?
Wouldn't it make more sense if he was selling grapes on tortillas and he wanted to maximize his profit?
Right.
That would make way more sense.
Right.
So
I'm like, who wrote this problem?
And that's why, honestly, those are the problems I make fun of.
They did a table.
So last year on a personal dry erase board, somebody kept writing, "What the heck are watermelons?"
Yes, I remember.
Do you know? Did I ever tell you the story behind that?
I don't remember.
So I was telling my kids, I'm like, yeah, when I give you word problems, I give you real word problems that you can actually see how they're used in the real world. Not Johnny has 8 watermelons and Susie has 5 watermelons. How many total watermelons does Johnny and Susie have? Because those are the problems that they always see. Mm-hmm. Those absolute nonsense problems, so they don't ever see the real way math can be used.
Right.
Which frustrates me.
I like this one. Question. Captain of a vessel tides with.
Are they using the rule of the 12ths? Probably not. They're probably using chart datum. They're probably using chart datum.
Depth of water may greatly.
Yeah.
High tide
chart datum.
Water at the top. A.m. That same at low tide. Right, a sinusoidal function. What is the depth of water at
Oh, you know what? I want to work that problem. I want to work that problem because that's actually very much like my Hopewell Rock problem.
That's what I'm saying. Okay,
so when does high tide occur? No, there ain't any questions. When does high tide occur? So I want to write high tide.
Where's at 5 a.m.?
At 5 a.m.
Do you want the depth of the water at that time?
Yeah. 10.6 meters. Okay. When is low tide? At 11:12 a.m. 6.5 meters. Okay. What's the total lapse? 6 hours? Okay. So. Yeah. Watch this. So I'm going to use the rule of the 12ths to actually do this. This is a cool little thing. So it's based on a clock. And this is actually how seafarers back in the day used to estimate tides. So the reason why it's called a rule of 12 is because it goes through a complete cycle in 12 hours, theoretically, right? So a regular clock goes 1 through 12, right? So if low tide occurs at 5, so I'm going to call this 5 a.m. So that means I'm going to go, so directly, yeah, this would be 5 p.m., 12 hours later, right? Mm-hmm. So at 4 a.m. and at 6 a.m., right? See what I'm doing? I'm going, then I have, let's just do 5. Actually, I'm going to do this and I'm going to shift it because it'll confuse people if anybody watches it. Because I'm doing a lot in my head.
Right.
So here's our clock. So we're going to call this high tide. We'll call this low tide. So 12 and at 6. So 6 hours, right? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
I see it.
Oh, yeah.
So I was like, why are you doing it?
Well, you know my story about me reading the clock backwards, don't you? Really? Okay, sidebar. Nanny had an epic parent fail. Epic parent fail. She got called into a parent-teacher conference for Tave. Because Tave kept failing the papers on how to read a clock, an analog clock. And my mom was like, no, she knows how to read a clock. She reads it at home all the time. It happens to me too. It happened to me too. My mom realized later on the reason why we couldn't read a regular clock is because the clock she had in her house ran counterclockwise. So I learned to read time on a counterclockwise clock. I can read a counterclockwise clock faster than I can read a regular clock. It was an epic fail. God, you can ask Tave about that because Tave remembers that too. It was an epic fail. Oh, is that not a classic Nanny story?
Classic Nanny story.
Okay. So the whole idea here is the water, we're going to assume water goes in and out in equal portions, when in reality it doesn't because you have different tides and forces and all that. So my difference in this is what, 3.9 meters? So I'm going to take 3.9 meters, and I need to go from 10.6, which is right here, all the way down to 3 to 6.5. Yes? That's 6.5. Oh. Right? So all I'm going to do is I'm going to take the difference and I'm going to divide it by the number of hours, which is 6. So 3.9 divided by 6 means I'm going to have a change of 0.65 meters per hour. Right? So from there, what I'm going to do is I'm going to subtract. I'm just going to put it into, it now becomes basically linear. And I'm going to do 10.6 minus 0.65x. Go to my table and plug in my numbers. 1 gives me, why did I do that wrong? Not yet. No, I'm going to ignore the 12 minutes. This is how I do the Hopewell Rock problem. You'll see in a second. You'll see in a second. Oh yeah. That's good. So that means I'm going to have a table, so I can create a table, right? So here's my X, here's my Y values. And I want to say at time T0, which I'm going to call high tide. So at high tide, I have 10.6. And then I can go at 1, at 2, at 3, at 4, yada, 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 right? I'm going to go just to 6. And then all I'm going to do is I'm going to subtract 0.65 each time. So I'll get 9.95. 9.3. Any questions? 8.85. not see 8, 7.3, and then that's fine. It's right at the end. And then 6 is 6.7. So I'm off by a hair. 3.9. Did I do my math wrong? The time doesn't. I'm only doing depths of water. I'm not doing times. 10.6 minus 6.5. Oh, it's 4. This is 4.1. That's why. Basic subtraction. Foiled by basic subtraction.
I'm trying to do everything in your head, sir.
I know, right? I tell my kids, don't miss a problem because of pride. Put it in the calculator if you're not 100% sure. Sad part is, I was pretty much 100% sure it was 3.9. That's the sad part. 4.1. So now if I do 4.1 divided by 6, that gives me 0.683 repeat. So we're going to do 10.6 minus my answer. This gives me 9.2 roughly. I'm going to do 9.2 minus 0.683. So about 8.5. I'm rounding these numbers to give you an idea. Answer minus 0.683. 7.8. 8.5, and we get all the way down. This 1, 2, 3, 4, 5. And I do it one more time. Oh wait, no, that's not right. I hit minus a negative. I went the wrong direction. 7.8 minus 0.68 roughly. About 7.1. Yeah, and then minus 0.68. 6.44, so about 6.5, right? All right, so this works out. So this gives me an estimate of the general flow, right? So from here, you can actually create the sine wave from max to min. See if I can remember these off the top of my head. To find A, it is the absolute value of max plus min divided by 2.
F of X, A,
sine. Yeah, they're doing this. Big A sine of, they're probably doing B theta minus C plus D.
Sort of. I over.
Yeah. Because I'm about to do that. I'm about to do that.
Oh.
Yeah, I'm about to do all that. Okay. So if I, and then, so my D should be, I think it's the absolute value of, no, it's not the absolute value. It's just max minus min divided by 2. I might have these switched. I might have them switched. So, because it's been a while since I've done this. So my max is 10.6. So I'm doing 10.6 minus 6.5. 10.6 minus 6.5 divided by 2 gives me an A of 2.05, and then 10.6 minus 6.5 divided by 2 divided by 2. I cannot use a calculator today. This should be 8.5. 5.5. This should be the 2.05. Now these might be swapped. I don't remember. When I actually put it in here, I'll be able to tell. So the A should be somewhere around 8-ish, and my D should be somewhere around 2-ish. It makes sense because it goes up 2.05 and I stretch it 8.55. 2.05 to be the very last number.
They just basically
Whatever. I'm doing it my way. All right, and then B is going to be, is it 2 pi over my period? Should be 2 pi over my period. Yeah.
C is a
Right. Yeah. So B is my period. So how long does it take to repeat? Well, it's going to take 12 hours to repeat. So this is going to be pi over 6 for B. The way I set it up. Because my period is 12 hours, so I put 12 in here, and I do pi over 6. And then my C for I'm going to do cosine, because cosine's easier, is 0. And then I will do sine in a second. So my cosine equation would be 8.55 cosine of pi t over 6. And this would be my tide in terms of t hours for cosine. For sine, I need my midline. So my midline, and then I got to shift it over. I don't feel like doing that. You just find the midline and shift it over. Any questions out there since y'all are watching? But this is the rule of 12s. And what I was going to do this year in pre-cal is, instead of me doing all this for them, I was going to teach them the rule of 12s and make them take the information from the tidal chart, from high tide to low tide, make them do all of this to create it. So all I need to know is high tide and the amount, low tide and the amount, and I can get an approximation right here. And within that 12-hour range, I'm going to be within like 1/3 of a meter,
right.
If that, like a couple inches. So, but when I start extrapolating, okay, Stein, I'll get you here in a second. But when you start extrapolating, trying to predict outside of that 12 hours, it gets really far off.
Oh, okay.
But this is actually how, long time ago, they used to be able to predict roughly when the tide's going in and out, and a lot of people still do this as a backup.
Oh, okay.
So Stein's got a question here. Yeah. Let me erase and I'll get it done for you, Stein. So if I do go back to geometry, that will be something I do, is I will teach them the rule of the 12s and make them do it. Yeah, pre-cal. Because the rule of 12s it's handy because you can use it. Moon phases are exactly on 28-day cycles, so it doesn't matter. But anything that's on a rough 12-hour cycle, you can use that rule of 12s. All right, so week 2, day 2, geometry. Do you just need an explanation, or do you need like a specific problem? I'm on day 3. Oh, it's right there. Oh wait, I stapled this backwards. I went 4, 3, 2, 1. All right, you're just confused. All right, cool. So on the second page here, I'm asking you to do rotations. Yesterday you were doing the mapping where you were creating the mapping, but when you do rotations and reflections, you have predetermined mappings. So on the page that I gave you right here, I give you the predetermined mappings because you're going to need these to be able to solve the problems. So I'm going to walk through the example to kind of... So I give you 10 of them, so I'm going to just pick one. I'm going to do... I'm going to do number 9, if that's okay with you. So this is number 9. And I'll tell you to rotate 90 degrees clockwise. That is an O, not an A. Okay, so if you're going to rotate 90 degrees clockwise, what you're going to do is you're going to go up to the top where it says, this first one says reflection, this one says rotation here. You're going to find rotation, you're going to go to the one that says 90 degrees clockwise, which is the set on the first bullet, second one down. And that tells me for that rotation, when I have an X and a Y, the mapping is going to be Y, comma, negative X. All right, so that's the rotation for 90 degrees clockwise. Done. I don't have to try to create the mapping like we had to do last time or anything like that. And then in the problem, I give you 4 points. I give you E, which is 2, 4. I then give you F, which is 3, 7. I give you G, which is 9, 7. And then I give you H, which is 9, 4. And I'm asking you to rotate this quadrilateral 90 degrees clockwise. That means I'm going to take each of these points and rotate it 90 degrees, but I'm using this mapping here. So I'm going to do Y, negative X on each one of these. All right, so now all you have to do is just plug everything in. So my E prime, this is telling me that my X value is now my Y value. So my Y is 4, so I'll put my Y first. 4, this tells me it's X with the negative. So I have a 2, so it becomes negative 2, and I'm done. Here, tell me my X is my Y, so 7 is first. So F prime 7 becomes my now X, because that's what this tells me to do right here. And it tells me to do the X, but a negative, so this becomes negative 3. This is my G prime, same idea. My 7 is my Y comes first, because that's what the mapping tells me to do. And then my X is got to be negative. And then my H prime, same thing, and this is just simply going to be 4, negative 9, and you're done. That's all it is. I think you guys probably you're just overcomplicating this. So that's how you do these other 9 problems. It's all within the mappings right here up top. Hopefully that kind of clears it up for you. You know, sometimes with us math people, we just think that's clear as can be, and it's just not that clear to non-math people. Oh, Coda's coming back. Getting in a spot. Can you do one of the word problems on week 2, day 3? Sure, why not? Week 2, day 3, one of the word problems. On the bottom here, huh? All right, it says a rectangle has a length that is 2 units shorter than its width. Nice. Right? And simplify the expression. So I'm going to do number 1. Why not? So it says, in my geometry classes, I always tell them, turn a word problem into a picture problem, because the picture makes it way easier. So draw it out. Become an illustrator. All right, so it says a rectangle, so I'm going to draw a rectangle. Here's a rectangle. It doesn't have to be pretty. I don't even have to label 90 degrees here, but I should technically. And of course, it's a parallelogram, and I digress. All right, it tells me it has a length that is 2 units shorter than the width. All right, so here's my width. Well, that's not my width. Has to be. Here's my width, and then my length is 2 units shorter than my width. So my length is 2 units shorter than my width, so it's W minus 2. I'm having all types of issues today. W minus 2. All right, it says write and simplify an expression that represents the area. Well, first off, you got to remember area, K stands for area, of a rectangle is length times width. Okay, so I know W is still W, but now my L, my length, is W minus 2. So this becomes W minus 2 times W. We do hippity-hoppity distributive property. This is left distribution, which is whatever. It gives me W squared minus 2W, and you're done. Not terribly bad. Not terribly bad. Hopefully that helps a little bit. The key to these, anytime they give you a picture in that, try to draw it out. If you could draw it out and label everything, that's so much better. Wait till y'all see the Algebra 2 for next week. Ha 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 ha. What else? What else? What else? Yeah, you should say yay. It's so much fun. Who was that, your mom?
Ever. Have my phone. You called me on.
What else, guys? More questions? Yeah, I've read through 2 and 3. They work the same way. I would like to see a much more fun problem than those. Those are like boring. What else, guys? What else? What else? What else?
President.
Woohoo! If you're waiting for the snail mail to tell you what to do, you're already too late.
Exactly.
Oh my goodness.
Well, I mean, not everybody has or watch news.
Yeah, but more likely those people they're not worried about the coronavirus because they're up in the hills somewhere or they're completely isolated and hermits like Ted Kaczynski was. He'd never have to worry about the coronavirus because he never went around anybody.
Oh, it tells me it's coughing your.
Yeah, vampire.
No, I know that, but I was coughing like spider. That's how I was taught to do.
Back in Le Cordon Bleu days. Yeah, if y'all have cooking questions, my wife can get on here and explain cooking to y'all. She graduated from Le Cordon Bleu. She is a certified chef, believe it or not. That's why since we've been married, I've put on like, what, 75, 80 pounds? Almost 90 pounds in 21 years. Not bad. Of course, I was 90 pounds in about 2 years. 22 years, sorry. We've been married 21.
Yeah.
There's 4 people. Well, it doesn't count me. It doesn't count me. Okay. So there's 3 other people. Oh. So I answered Taylor's question. And then nobody cares. Then I told them they should wait till next week's packet. It's so much fun. And I did an evil laugh. Wah ha ha ha. I tried to move the Kodacam, but I couldn't get it to move. And then I realized I had zoomed in on the Kodacam and I just had to zoom out. I can do all this stuff, but I'm struggling with just the zooms. Hey, you know what? You can at least read my chat now. That's a huge plus. So it actually looks good. It's funny, I'm pointing to the wrong direction. It looks good. Because I'm pointing to the screen where I can see it. I don't know. She doesn't like this room. And if you bring her in here, he's going to get excited and he's going to start knocking cameras over and everything else. He'll think it's playtime. That's 45 minutes. I'll stay a little bit longer in case these two have questions, but you have another problem for me to work? As long as ain't nobody coming over here and bumping it, it's perfectly fine. Oh boy. Yeah, I know.
Oh,
This looks like it's going to prolong for a longer time. I might have to actually bring the other desk in so I have actually a place where I can sit and work.
big old desk. Oh, we have the one the same.
I need the one maybe the same size I'm currently on. I thought the kitchen one was big.
No.
All right, Taylor. Let's see. Week 2, day 3, geometry. Can you explain it? Week 2, day 3. Okay, so this one here is a combination of the first 2 days. You're going to have to do an order. You have to do everything in a set order. So I'm going to tell you what order to do your transformations in, and then you just do the transformation that we've done over the last 2 days. That's it. So I'll work. I'm not going to do 5 because 5 is fun. So I'm going to do. Why not? I'll do number 3 just because, and just kind of walk you through it. But this is actually a composition. If you're not told, like on this page, I tell you the order. If you're not told, you have to do order of operations, which is PEMDAS. All right. So number 3, I'm telling you, I want you to reflect. Over y equals negative x, and then you're going to go look at the mapping for that. Y over negative x, because I don't memorize these because I don't actually do reflections this way. That's going to map. My mapping for this is going to map to, and I'm just looking back at those rules I gave you before. It gives you negative y, negative x. Okay, so we have to do that first, and then we're going to do a translation. This tells me horizontal, left, 3. So horizontal, left, 3. Horizontal is your x, left is minus, and 3 is your units. So our mapping then would become x, y is going to map to x minus 3 comma y, because it didn't tell us to do anything vertically. So these are my 2 mappings I'm going to do. So I'm going to do one of the points because I'm asking you to do it with 4 points and kind of to show you. So on point E, I have 2 comma 4. I want to do the reflection first because it's the first thing listed. So I'm going to map it to negative y, negative x. And that's going to map to E prime, which now this tells me to take the negative y, so I have negative 4, and then a negative x, negative 2. All right, I'm now going to take this answer, and I'm going to do this transformation too. So now I'm going to have E prime, which is negative 4, negative 2. So I'm going to take my answer from this to do this to, and I'm going to map it to x minus 3, y. So I'm going to take my negative 4, put it in here, negative 4 minus 3. This is going to be E prime prime, because I've done it twice now. Gotta love, this is Newtonian notation. Gotta love it, it's clumsy. This gives me negative 7, and I'm going to take the negative 2 for my y, negative 2, and I'm done. And you just do that with every point. So on the packet, I give you the order you have to do things in, and then that's it. Just do your first one, whatever the first thing is, take that prime, bring it down, do the second one. And on number 5, I have 1, 2, 3, 4, 5 things you have to go through. 5. So you would end up with E prime, 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 prime.
Graph those?
No, I didn't tell them to graph it.
Oh, okay.
Because if they can do this, then it's just plotting points.
Right. How would you notate it on my? I just.
Yeah, E prime and then E prime prime.
Oh.
So yeah, that's what you would do. So hey, Taylor, give you a hint to make your life easier. After you do E prime 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 on number 5, change over to Leibniz notation and do E parenthesis 4. E parenthesis 5. Makes way more sense than doing prime, 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 which is Newtonian notation. No, that's bad form in math. It switches over in 4. Think of calculus. First derivative, second derivative, third derivative.
Right. No.
And then you will start doing parentheses with 4, 5. And you have to do the parentheses so it's not an exponent. Newtonian notation.
I've never I don't think
This isn't taught in college. This isn't done in college.
or high
This is
school.
only done in. It's actually supposed to have been done in high school. It's geometry. It's.
Well, I just know I changed my. Oh, I had a.
Wow. But yeah, you're supposed to do it in geometry.
like
That's been there. That's been there for a long time.
Our classroom was in a snack bar, so.
Really?
Yeah.
Oh, you told me about that class.
Yeah.
They held class in a snack bar.
Yeah.
Quality education.
It was all done on transparencies and.
Oh, that's
Yeah, she was
showing your age.
She was. I know she was so worried about gossip.
I worry about the gossip at work too, but at least I teach something.
Thank goodness.
You should have seen that notation when it did you. Oh, in pre-cal, did y'all do rotations of conics?
No, we didn't.
Oh, because you had to use that exact same notation and rotation of conics.
One of the last things.
Parametric.
What were you? Piecewise function.
Oh, piecewise functions.
And then,
Piecewise functions technically algebra.
I was talking about pre-cal.
Still, piecewise really.
We did it.
Yeah.
No, so what is the last?
Well, towards the end of
So what's
pre-cal,
the thing where you slice it, add the thing?
slice and sum, finding areas of composite figures. Are you thinking of calculus where you're slicing up and you're summing the area under the curve?
Yes.
And then you're doing disc and shell?
Yes. There you go. Disc and shell.
That's calculus. That's not
We
pre-calculus.
did it at the end.
No, you didn't. No, you didn't.
Yes, we did.
Because you have to do an integral for that.
I don't remember.
It's been a hot minute too. I couldn't do that off the top of my head. I couldn't do disc or shell.
We have to have the curve and then we have
Yeah.
to break it up.
You have to break it up because if you have a curve that goes underneath the x-axis, you end up getting a negative area, which actually gives you the wrong displacement. So you have to make sure you're adding them up correctly.
Right. Thanks so much.
Man, I haven't done that in a long time. It's just annoying. What I always hate is when they wanted you to do around the y-axis. When they wanted you to figure it by using the y values instead of the x values.
Stop.
Just found that annoying.
Better way to. I even teach.
To make you understand that the better way is the better way. Because other people are like, God, this is so hard. This is so hard. But you appreciate it when you have to do a table over and over and over again.
Yes.
And then you get the other way, you're like, ooh, so much easier.
Yeah, it was because we did like 20 problems.
You sound like my students. I tell them, it's like, I tell my students, I don't know what you're complaining about. I gave you 3 problems. They're like, it's A through I.
That one time when you were in, I'm like, really, James? Really?
Guys, if you don't have any other questions, I'm going to shut the stream down. There's only 3 of us on here because I'm not counting my wife because it shows me that she has 4. Because I got to go do some adulting. I'll be back up at 5 o'clock again tomorrow if you have more questions. You can email your teachers, things along those lines as well if you have any other questions. All right, I am out. Time to be an adult.